Okay, second video here then on resolving forces, and for me this is an absolutely key concept. You need to be able to get your head around this and see what's happening. So here's our scenario. We have a chair here. There's a bird's eye view and there are 4 people pulling on this chair. We want to know which direction it goes. So someone's pulling 10 newtons this direction, someone's pulling 8 newtons this direction, someone's pulling 3 newtons this direction, someone's pulling 5 newtons this direction, and we're trying to work out what way it goes and with what force. I mean, my best guess is maybe this sort of way here. There's a 5, the 3 is quite small, whereas the 10 and 8 are a bit bigger, so I'm thinking maybe this direction here, but that's what we're trying to work out. We could get the 10 on the end of it, stick a 5, stick a 3, stick an 8, and then see start to the end, but that's not the most efficient way of doing it. We'll be there all day with all the geometry that we have to do. So what we're going to do is resolve in 2 orthogonal directions, and this is the bit you need to understand and practice loads and loads and loads. So I'm going to resolve this horizontally. First of all, we take it nice and slowly and take each of the 4 forces and see what effect then they're going to have. I've done my arrow this way, so I'm taking this way to be positive, so the 5 and the 10 are going to be pushing that way, so they're positive, and the 8 is going the other way, so it's going to be negative. The 3 we'll chat about in just a wee second. So first of all, 5 is just going straight that direction, so that's going to be just a 5, it's not resolving any direction there. Plus 10. I'm resolving the 10 horizontally. Did I go across the 60 going there? I did. So it's 10 cos 60. If it's perpendicular, then it has no effect. You can do it if you want. You could do 3 cos 90, but cos of 90 is 0 anyway, so you don't get anything. And then it's going to be take away 8, and we're resolving this 8 horizontally this way. Did I go across the 50? I did, so it's going to be 8 cos 50. So I'm going to put this into a calculator here, hopefully. I'm not very good at this, but we'll see. 5 plus 10 cos 60 minus 8 cos 50. And what's it given us? It's given us 4.86. So if we resolve all 4 forces this way here, it's equivalent to 4.86 going this way. Come out as positive, so it's going to be going this way here. Resolving in this direction here, I'm going to do a wee dotted line going up here. It might just help us, because we're kind of going that way. Alright, so what ones are we going up? The 8's acting up, the 10 is acting up, and the 3 is acting down. The 5 again is perpendicular, it's going to have no effect. Hopefully you can see that. So what do we have for this one? We have 10. Did I go across? So the angle given with the 10 is a 60. I'm resolving it this way here. Did I go across 60? I didn't. So it's going to be 10 sine 60 plus, which other one is pushing up? It's the 8. Am I going across the 50? I'm not. So it's 8 sine 50. 5 is no effect, and then the 3 acts straight down, so it's going to be minus 3. Let's put that into our calculator and see what we end up with. So we have 10 sine 60 plus 8 sine 50, take away 3 equals 11.79. Okay, so there are 4 people pulling on this chair. That is the same as 2 people pulling on the chair, one pulling this way with 11.79 and one pulling this way with 4.86. So I'm going to change this diagram to this. So we've changed our diagram of 4 random forces into 2 orthogonal forces. So we have 11.79 and we have a 4.86, and we need to find the resultant of those 2 forces. So 2 people are pulling on a chair, one with this force and one with this force. What way is it going to go? I think it's going to go this way here. 11.79 is a good bit bigger than 4.86, so it's not going to be 45 there, it's going to be kind of further up that way, as we suspected, kind of along this direction here, and we'll work it out in a wee second. We now do our tip to tail thing. Okay, so we lift this and we put one tip to tail. So I'm starting here. Again, this is a really hard bit. People find this really hard. Go across 4.86 and go up then 11.79. And my resultant force is from the start of the first one to the end of the last one. So it's there. That's the resultant force I'm looking for, and that is the angle then that I'm looking for. So the resultant goes from here to here, again in this direction here, and the angle is above the horizontal. So there was my horizontal there. Whenever I work out that angle, that's what I'll be finding. Okay, so to work out my R squared equals 11.79 squared plus 4.86 squared. R squared equals 162.62. That means my resultant force is 12.8. So the resultant then is 12.8 newtons. So if 4 people are pulling a chair, that's the same as 1 person pulling on the chair with 12.8 newtons. What direction then are we going? So let's label our sides. That's O. That's A. You could use H, of course, we've just worked it out, but it's better to use what we have. And so we're going to go for tan theta is O over A. Tan theta, because remember O and A, is 11.79 all over 4.86. Theta is tan to the minus 1. 11.79 all over 4.86. $67.6 degrees. I'm just going to try and squeeze this in at the bottom then, as I said last time. So resultant force, maybe a wee statement. Is 12.8 newtons acting 67.6 degrees above the 5 newton force, and that's done. Again, loads of key concepts there, and really important you understand. We'll be practicing that an awful lot. Start off with 4 forces, we change that into 2 orthogonal forces. So sorry for going on about this one more time, but these are 4 people pulling on a chair. That's the same as these 2 people pulling on a chair at right angles to each other. That's the same as 1 person pulling in a chair, so we now do tip to tail, stick this on the end of this, that's it down here. There's a wee bit people find very tough going from there to there. They feel like the angle, the resultant's going that way, but it's not, going from there to there. And that's the same as 1 person pulling in a chair, 12.8 newtons, that's 67.6 degrees above the 5 newton force, or as it looks here then, the horizontal.